Okay, so today is fourth week Friday. We have our midterm exams scheduled for next week, fifth week Friday. And then, so I guess I can talk about that briefly now, and I'll talk about it a little bit more next week. It's going to be short answer. And basically what I will do is I will write code, and I will ask what will our output. These will be, I don't know, I guess somewhat tricky. A lot of students have complained in the past about the questions that I put on there. They said I tested concepts that were, you know, tiny little details about R. And I guess that's true. I think the assessment that is not true is that it is unfair or useless. Because if you were ever to go for a job interview that included a technical component to the interview, they will give you a test that often asks for these tiny, complex, little, minute details of the programming language. And you know, when you are armed with a console and you can type things in and R outputs an error or something like that, you know, it feels like you don't need to know these details. However, when it comes to debugging code, when it comes to reading through your code and being able to figure out where the problem is, where the error is, it's important to be able to read and understand and predict what R is going to be able to output. And if you are a company looking to hire an applicant and you have one person, both people claim to be experts in R, but you give them this kind of test on minute details, you're more likely to hire the person who knows the minute details versus the person who does not. And I think it's a worthwhile exercise to be tested on these tiny little details. So, you know, you can go through kind of the examples that I've run in class where I did small little things, right? I said, you know, what is the type of, like if I subset a list using single square brackets, what is the type going to be? It's going to be a list, right? You subset a list with single square brackets, no matter what's on the inside, what you get back is a list, right? If you use the double square brackets, then you're going to get the type of whatever's inside that list component, and things like that. So I will test you on those kind of minute details, and you can, you know, we'll talk a little bit more about it next week. And then today we're going to cover this topic of data wrangling with R. And in my opinion, this is probably the most practical, possibly the most useful lecture of the quarter. And so, you know, pay attention. I wanted to talk a little bit about debugging. And I realize this is coming too late, but after all of these emails and office hour visits and reading through what's going on in Piazza, I think we could stand to benefit from some advice on debugging code. And you know, you've already submitted your tic-tac-toe assignment, so it won't apply there. But you know, for future assignments, you know, having a little bit of tools to debug code, I think is worthwhile. And so I'm trying to figure out where to fit that lecture, because I had the quarter pretty planned out in terms of all the content I wanted to cover. So I'll try to squeeze something in before it's too late as far as how we can go about debugging some code. But anyway, we'll start data wrangling with R. Today's lecture, we're going to cover two packages. One is called tidyr, and the other is called dplyr. And these are packages created by Hadley Wickham. And I don't know if you've heard of Hadley Wickham, but he works at RStudio, and he is responsible for the creation of many packages that have really, I think, reshaped the way we handle data in R. And I think he has made R a lot more powerful and useful in terms of its ease for manipulating data, as far as data science goes. And so, whatever he does, he thinks very thoroughly about how functions should behave, and before he actually writes anything down. So everything that he's created has been very, very, very good for R, and I strongly recommend learning his packages and their use. And so basically the collection of packages that he has created is known as the tidyverse inside R, and I don't know if you've heard that term, but the tidyverse includes packages like tidyr, dplyr, ggplot2, forcats, Tibbles, all sorts of stuff. So anyway, I'm actually just stealing the slides that this man Garrett Grolmund has created for a webinar that he put on, because it was a great webinar, and I felt there's nothing I can truly add to his series of slides that would make it better. So I'll kind of just repackage his presentation, because if it's great, why bother reinventing it, right? A lot of this you can just search for webinars on the RStudio. If you go to the RStudio website, they have some resources for learning more, and they are all excellent. And so I strongly recommend checking that out. There's also a book called R for Data Science, written by Garrett Grolmund and Hadley Wickham together. It's kind of like the dream team of R stuff, and that is available free to you guys as long as you're connected to the UCLA network, and I think it's worthwhile. You guys know about ProQuest, right? I've linked to a book here on in the syllabus. So if you go to ProQuest.Safari Books Online, you can just type in R for Data Science, and this will have, basically this has the entire O'Reilly catalog of programming books. And so here is R for Data Science, and you can read this book inside your web browser. You can't download it as a PDF, and I get that, why they won't let you do that. But anyway, the entire book is here, and this works through using basically all of your stuff. So anyway, ProQuest.Safari Books Online. I've linked to the R graphics cookbook that way inside the course syllabus, but while you're there, you can search for R for Data Science, and it's a great textbook. Okay, so anyway, let's get started. Data wrangling with R. My name is not Garrett, but we will look at these two packages, tidyr and dplyr. There are cheat sheets that cover, kind of summarize this. This is the screenshot of the old cheat sheet. The new cheat sheet is a little bit more updated. But anyway, the first thing is that when you deal with tidyr and dplyr, the output look like data frames, but they're technically called Tibbles, okay? A Tibble is basically a data frame. If you ask the class of a Tibble, it's going to say Tibble. It's a vector. The first class is going to be Tibble, but then it will be followed by data frame. So basically all the methods that apply to data frames will also apply to Tibbles, but Tibbles have its own special methods. In particular, what Tibbles do different from data frame is that if you name if you say print out the name of a data frame's default behavior is to print out as much as it can, and usually it'll stop after 1,000 rows, okay? And so sometimes if you're working and you type in the name of the data frame, it just flushes your entire console, and you're just filled with like hundreds of rows from the data frame, and maybe that's not what you want. So a Tibble has some smart properties, and it says, oh, this is how big your window is. we're only going to print the columns and the rows that fit in the, actually it's just the columns that fit in the window and just the first 10 rows. And so it plays a lot nicer in the console. Also, a nice thing is that the default behavior for data frames is it turns strings into factors. And we talked about how this could be problematic. And Tibbles don't do that. Tibbles leave them as strings. So basically, it's a data frame, but with a few nice features. And so anytime you're working with dplyr, get used to working with Tibbles as well. Okay. Also in RStudio, you're probably familiar with the CapitalV view command. You probably never actually type this, but when you load a data frame in RStudio and you click on the name in the environment, it shows up in the data viewer there. Okay. And we've covered the pipe operator already when we were dealing with rvest, and that just allows you to, rather than having to write the argument this way, the function select from data frame TB or the data, your data set TB, applying this, you say TB piped into the select function. Right? So this is usage of the pipe operator to pipe things in. Okay, so let's talk data wrangling. This says, maybe goes by other names such as janitor work or data munging. It's basically, the idea is you've got data from some kind of source, it's messy, it's hard to work with, and you want to get it into a format that is easy to work with, okay? And the format that we are trying to get it to work in is, we have decided to call the tidy format, okay? And so it says data sets come in many formats, but R prefers just one. If you want to follow along, the data tables that we're using are available in this library, EDAWR. It's not an official CRAN package, so you have to run this command install_GitHub to install a package from the GitHub library. So let me open this up and so I believe I've posted this code up on CCLE, so you can follow along if you desire. You don't have to, you can just watch as well. Okay, so anyway, I'm going to load up this way, and we can kind of take a look at the storms data and the cases data, pollution and TB. And so these are kind of like mini data sets just so that they are illustrative of what these functions are doing. Okay, these are some of the different data sets that we are looking at. So here is storms. Here is the cases table. Here's the pollution table. And let's just kind of take a look at. So if we look at storms and we ask what are the variables that appear in the storms data frame, we see that the variables are storm name in the first column, wind speed in the second column, air pressure in the third column, and the date in the fourth column. Okay? If we look at the cases table and we ask what are the variables that appear in the cases table, the variables are the country, then the year, which appears across the columns, and then the last variable that appears is the count, or the number of cases of, in this case, tuberculosis, I believe, and that appears as kind of the intersection between the year and the country. So we have three variables there. Okay? And then lastly, in the pollution table, it says there's the city and the particle size and the amount, but we might say, what are the variables that appear here? Well, we have cities. We've got three cities, New York, London, and Beijing. And then we have the amount of large particles, which are kind of stored in the odd rows. And then we have the number of small particles, okay, which appear in the even rows, okay? And so we can say these are the variables. And how are we supposed to extract these different variables? If we want to get a list of all the storm names, it's easy. We can just go to the table storms and say $storm, or the wind speed. We can just use $ notation to pull these things, right? However, if we want the variables, the values from anything else, it's a lot more complicated. We would have to get these names without kind of the first header and all of this. We have to unlist all of this stuff. Over here we have to specify we want the even rows or the odd rows. It gets quite complicated trying to extract information if the data is not in this first format. Okay? So we call this first format tidy data, where each variable has its own column. Okay? If each variable has its own column, it's in tidy format, and this allows us to perform what we call maybe window operations, where we can just say, you know what, let's say we want to calculate the ratio between air pressure and wind speed. We can just give it the vectorized operation, pressure divided by wind, storms $pressure divided by storms $wind, and R will match up each row. It will do 110 divided by, 1007 divided by 110, 1009 divided by 45. These numbers got all messed up, but basically it will do the operation element by element, which is exactly what we want to do. So these are the properties of tidy data. Each variable has its own column. Each observation is in its own row, and each type of observation is stored in a single table. So here, this whole table is just devoted to different storms. Okay, we're not mixing in storms along with other kinds of information here. So this is what we call tidy data, and this is the format that we want to work with. And so the package tidyr helps us to transform data that's in other formats, such as the cases or the pollution table, into tidy data. Okay, and this could be a useful thing. So tidyr has basically two main functions, gather and spread, that allow us to reshape the layout of the tables. Okay, all right, so I want you guys, okay, everybody has to log into the online poll here, sorry. Okay, and we'll take a few minutes. So log into the online poll tool, and your first question is going to be to think about this table cases, right? And the question is, if we reshape the cases table into tidy form, how many columns will it have, and how many rows will the resulting table have? Okay, so I gotta log in. Authenticate. And okay, so this is what we have, and so your first question, let me see, is going to be this one. If we reshape the cases table into tidy format, how many columns and variables will the resulting, how many rows, columns and rows will the resulting table have? Okay, and then, all right, so let me create a poll, sorry. Okay, so this poll should be open, so again, each variable has its own column, and each observation has its own row.
What is it?
So if you think about what are the, we have France, that had 7,000 cases or cases of, I think, tuberculosis in the year 2011 or something like that, okay? This might be fictional data, so. So each variable has its own column. Each observation has its own row. So how many rows and how many columns will we have in the resulting tidy data set, right? Don't include the header row or anything like that. Is everybody able to log in and respond to the poll? Let me kind of just get a quick glimpse of how many people have responded. Okay, please get your responses in. So we want to reshape the cases table so that each variable has its own column and each observation has its own row. Okay, we'll close the poll soon, so okay. Did everyone get their responses in? Who hasn't? Okay, so then I'm gonna go ahead and close the poll. All right, well let's take a look at what it would look like if we reshape the data, okay? So what our first observation, we're going to have the column headings will be the country, the year, and the end. And that actually was given away on the slide. It says we have 3 variables, country, year, and end. So we're going to have 3 columns. And the first observation is going to be this cell. In France, in the year 2011, we had 7,000 cases. Okay. Then in Germany, in 2011, we had 5,800 cases. In the US in 2011, we had 15,000 cases. And then we continue in France in 2012, we had 6,900 cases, and so on and so forth. And so we would have a total of 9 rows and 3 columns. 3 columns, 1 for country, 1 for year, 1 for the number of cases, and then 9 rows. 1 for France 2011, Germany 2011, US 2011, and so on and so forth for each of these observations here. Okay, each variable is its own column, and the tool that we use, this is known as gathering, because what we are doing is we are taking all of these values that are currently spread across 3 columns, and we are gathering all of these numbers into 1 column. So the verb there is called gather. And what happens is the column headings become values to distinguish the rows. Okay, and this is known as the key. And over here, the values that we gathered end up in this column, which we now call n. And so the command is gather the cases table, and we just give it 2 names, year and n. This could be anything we want to say. It could be just y, it could be yr, it could be the year upon which this is. It's just a character string. You can say anything you want, okay? If you want to write año, you can write that. And as far as the this value goes, also, it's just a character string. It doesn't matter, okay? This part indicates which columns are being gathered. And so we have 2:4, and that's what we have. So this is the data frame that we are reshaping, the name of the new key column, the name of the new value column, and the name that we are collapsing. And when we do that, this is our table, and it gets collapsed into here. And you can kind of try this out. So we have cases. This is our frame here, and if I do gather cases, and we're going to call this year, n, and we want columns 2 through 4. Whoops, I have to library tidyr. course. Okay. So when we gather it, this is what we get. What would happen if I gather, rather than columns 3 through 4, I gather columns, 2 through 4, I gather columns 3 and 4 only. Okay, so let's just take a look. What if I choose only to gather the values in columns 3 and 4, rather than columns 2, 3, and 4? Well, what this will do is we'll gather these sets of values, and so the resulting table will have how many rows? It will have 6 rows, okay? And basically, the columns that I did not gather will just be repeated, okay? Much like the country name, okay? So here, what happens is that the columns that I didn't gather, being country and 2011, these get repeated, okay? So I have year and N, and I'm going to have 6 rows in the resulting table, and then the columns I did not gather just get repeated, okay? Like over here, the column I didn't gather, being country, got repeated 3 times, and here, these columns got repeated twice because I gathered them together. Does that make sense? What has happened? I gathered column 2012 and 2013, but 2011, 7,000, 5,800, 15,000 just got repeated, 7,000, 5,800, 15,000. Does that make sense? What we did with gather. Okay. All right, let's do one more here, okay? Here I've got the pollution table, and we want to make this tidyr by basically, we're gonna split up this column of amount into 2 columns, the number of large particles and the number of small particles, okay? And so, so here you have a second question. And let me open up another quick poll here. And the question is, how many columns and rows will the resulting tidy data frame have? So currently we have New York, London, Beijing, large, New York small, London large, London small, Beijing large, Beijing small. And we want to change it to city, number of large particles, number of small particles. Okay, have we gotten our responses in? No? Okay, all right. Get your responses in, please. So, I mean, there's a big hint right here, right? It kind of tells you the resulting variables that we'll have. Okay, we're gonna get your clicks in. Let me just kind of verify, see how many. So we got 10 stragglers. Okay, I think that's everybody. Did everyone get their clicks in? We'll go ahead and close the poll. Okay, so well, let's take a look. What we're going to do is we will have 3 columns, city, number of large particles, number of small particles. And then we say, okay, New York had 23 large and 14 small. London had 22 large and 16 small. Beijing had 121 and 56. And so we are going to end up having 3 rows, one for New York, one for London, one for Beijing, and 3 columns. The city name, number of large particles, and number of small particles. 3 rows, 3 columns. Okay. This action is called spread because we are taking the values in one column and we are spreading it out across 2 columns. The way it's going to work is we say spread, we take the name of the pollution, of the table, okay, the data frame that we are reshaping. We're going to take the column name that will have the key values. The values in the size column become the column headings that result. And then these are going to be the values that get spread out, okay? So what we see is the names or the values inside this column, inside the key column, we see large and small. They become the new column headings over here, large and small. And the values that show up in amount get spread out across those 2 things. Okay, and so when we do this, we have spread, pollution, size, amount, and it spreads out accordingly. Oops. Let me just kind of show you what happens. So here I'll do spread, pollution, size, amount. This is the original pollution table, and what we've done is we've spread this, okay? I'm going to create a second table. I'm going to copy pollution into pollution 2, and here I'm going to change one of the values into capital L large, okay? Okay, so if we look at the table here, it looks almost exactly the same, but here I've got New York with a capital L large, and then small, large, small, large, small. Okay, and so if I use the same command that I did before, spread the data from the pollution table using the size column and the amount, what it's going to do is it's going to say, okay, how many unique values do I have in the size column? And rather than seeing large and small and seeing 2 unique values, it's going to see 3 unique values. It's going to see capital L large, lowercase large, and lowercase small. And thus the resulting table, after it's spread out, will have 3 columns. We're going to have a, oops, I have to use the table that I've modified, pollution 2, and we have a column for lowercase large, a column for capital large, and a column for small. Okay, and so it says the values for Beijing are 121, 121. We don't have a value for capital L large. Okay, and then for New York, we don't have a value for lowercase large, but we do have one for capital L large. Okay, can you guys see what has happened here? Okay, and that's because here we were inconsistent with the naming of these things. So let me just kind of change that back to lowercase l, and then if I run the command spread here, and if we are consistent in our naming, then oops, then it works. Okay. Something similar will happen if I changed the name. Instead of New York, if I write NYC, okay, I've got this is consistent, large and small is consistent in the size column. But then if I were to spread this out, what's going to happen is I'm going to have 4 rows. I'm going to have a row for Beijing, London. I'm going to have a row for New York where I have the small particle size, and I'm going to have a row for NYC where I have the large particle size. Okay, and it says the other value is missing because spread doesn't know that New York and NYC refer to the same thing. They're just trying to find identical matches in that column and spread them out accordingly. Okay, so does this make sense on how spread is working, and you know, how it's important to have kind of consistent naming across these things? Okay, so to go from something like this, we can do spread, but if we wanted to, we could gather them back this way. Okay, so spread and gather are kind of complementary actions. You take the values in one column and you spread them out. Gather takes the values in multiple columns and gathers them into one. All right, is that okay? This presentation covers unite and spread. They are not important. They just spread based on character information, so I'm skipping over it. Okay, now we have to talk about dplyr, which is very important, and I'm afraid we'll run a little bit short on our time. With dplyr, this allows us to kind of summarize some information, okay? Select pulls out variables, so it's like subsetting based on variables is select. Filter subsets the rows. You extract out the rows that you want using filter, okay? Mutate creates new variables based on existing ones. And summarize, this is kind of the most powerful tool. It will summarize all of your data into basically a summary value, okay? So here, if we want to just pull out the storm name and the pressure, so this assumes everything's in tidy form, okay? Once you get your data in tidy form, you can say, I want to select from storms the storm name and the pressure. And that's what you do. You say select from storms, storm, and pressure. If you, you can also say, I want to select everything but storm name. You just put a minus in there. You can also say, I want basically columns 2 through 3, and you can write 2:3, or with select, you can say wind:date, and it will say, I want the columns from wind, from the wind column to the date column. So you have this. There's other features such as that come with dplyr. You know, I want columns that end with the string such as time, okay? Or I want columns that start with the letter K, something like that. You got a whole bunch of columns, you can say I want columns that start with the letter K or something like that. Filter allows you to select rows. This is much like subset, okay? Here you say filter the storms where the wind speed is greater than or equal to 50, and it does this accordingly. You can say we want where the wind speed is greater than 50 and the storm name is inside this vector, okay, is one of these values in this vector, okay, using, and so you can give it, provide multiple conditions just separated by a comma. And then you have all of your kind of logical tests in there as well. I know I'm going over this quickly, but I think you guys are familiar with the subset operation, that these things are okay, because filter works very much like subset. It's just dplyr's version. Mutate allows you to create new columns, and so you can say, I want to create a new column called ratio, and this is made up of pressure/wind, okay? If you wanted to do this without dplyr, you'd have to say storms $ratio is equal to storms $pressure divided by storms $wind or something like that. Mutate makes it easy to do this. A nice thing is that you can use a column that you just created in another thing. So here we want to create a column called inverse, where we just take the ratio and we raise it to the -1 power. Okay? Normally in base R, you would first have to create the table with the column ratio first, and then you could create the next table, which includes everything and includes the table for inverse. Mutate allows you to do it in one step. Okay, and then again, we have some nice little functions here that you can kind of play around with, such as cumulative mean and stuff like that, okay? All of these functions here, these are known as, quote, window functions, meaning you take a vector of values and it will return a vector of values, such as the cumulative sum takes a running or cumulative sum. So 1, 2, 3 will return 6, you add 4, you get 10, you add 5, you get 15, so on and so forth. A sum takes all values and just returns 1. cumulative sum will take a vector of values and return a vector of values, which is important because if you're adding a column, you need a value for each row. So here with the ratio, you're taking a vector of values pressure and a vector of values wind, and you're getting a vector of values ratio. Okay. I might go a little bit over, but stick with me because this is key, all right? The summarize function takes all of your values, and so here we have 6 values, and it produces 1 value, right? That's what a numeric summary does. You take the mean of 10 values, it takes 10 values, and it makes 1. You take the standard deviation, it takes 10 values, and it returns 1 value, and that's what we have. You ask for the median, it takes these 6 values, it returns the median of those 6 values. You take the variance, and it returns 1 value. So summarize functions, or n, which is going to be the count, it says all of these values, there's only 1 value now, just the number 6. Okay? These are called summary functions. It takes a vector of values and returns a single value. And you say, well, that's not that impressive. I can just do mean storms $wind or something like that. That's totally fine. This is where, skip over this arrange stuff. Arrange is just sorting it, okay? And this is all with pipe operation, okay? Oh, and for pipes, the shortcut for pipes is Command-Shift-M or Control-Shift-M on your computer. So you don't have to type this out. You can just hit Control-Shift or Command-Shift-M for pipes. And we've already covered pipes. You can kind of flip through these slides. The power of the summary is that you can say, I want you to group the values by the city name. So rather than taking all 6 values and summarizing it into 1, we can say, hey, group them by city name, and I see 3 groups, New York, London, and Beijing, and give me the summary values for each of those groups, okay? And so what this does is it basically, dplyr will split your data frame into the groups based on the city name or whatever argument you give it, and then it will conduct the summary here. This used to be a very complex procedure. It was very painful to have to create subsets based on each value, and then you can run it through the mean and so on and so forth. Here, dplyr has really made this a lot easier by running the group by and the summarize function. And so the way it works is first is we take the table pollution and we say group by city, okay? And when you do this in R, it doesn't look like much has changed. So if I start off with pollution, this is what it looks like. And if I say pollution, Command-Shift-N, group by, I think I have to run library dplyr. Okay, so I've got pollution, and I'm going to do pollution, feed this into group underscore by, and now I want to do city, okay? When I do this, it looks exactly the same as before. The only change here is now it says groups city 3. It says we've grouped it by city, and there's 3 groups, okay? But the power comes from when we say summarize, okay? So we would take this grouped by thing, and I would feed it into the function summarize, which is spelled with an S, okay? And we say what you want to do for the summary is we want to create a column called mean, and the way we calculate the values in this column mean is by taking the mean of the amount column. And so I would say mean is equal to mean parentheses amount. So it takes this column amount, and it says, okay, New York, I've got 23 and 14, so the mean of those 2 values is 18.5. For London, I've got 22 and 16, the mean of those 2 values is 19. And for Beijing, I got 121 and 56, the mean of those 2 values is 88.5, okay? This was a lot more challenging without dplyr. So again, all you do is you take your table, throw it into group by, and throw that into summarize, and you specify the name of each new column. So here we're going to end up with 3 columns, mean, sum, and n, and you tell it how are you supposed to calculate the values that go into that column. Here we're saying take the mean of the amount column, take the sum of the amount column, and n is count how many values you are summarizing. So when we do that, it does this for each thing, and then it puts them into one table. Okay, and so this is what we've done. If you want to get rid of groups, you can use ungroup, and you can group by multiple things. So here we have a complex table where it's got 3 countries: Afghanistan, Brazil, China, also years 99 and 2000, and sex, male and female. And here we can group by the country and the year, and it creates 6 different groups. And if we summarize the first thing, it will, it will create a table with 6 rows. And then we could summarize it one step further, and it will create a table with 3 rows, because here we've got groups for country and groups for year. So 6 groups here, and then further that to 3 groups here. Okay, take a look through this this thing. You can skip over this stuff on joining data, so don't worry about that. But I would really say study the dplyr, the group by, and the summarize. Those pairs of functions are incredibly powerful. Okay? All right, we'll end here, and we'll wish you guys luck.
Thank you.
Yep.